Yeah, good morning, day students. This is Dr. Vijaya Babu. Today we'll try to go ahead with some more deeper concepts of current electricity. So that is energy, charge, and the potential. Okay, why the importance of energy of the charge is important in any electrical circuit. So that is the concept what we'll try to go ahead now. So that today we'll try to discuss about the concepts of energy, potential, and charge. So when I write this energy, potential, and charge, what is the relationship among them? So this is also one of the most important thing. So to make you understand this concept, so I'll try to go ahead by taking a small electrical circuit once again into picture. So the small electrical circuit, what I try to consider is a battery having some voltage across it. Let us assume the voltage across the battery is 10 volts. It's a 10 volts Nippo battery. Okay, 10 volts. And across this battery, I will try to connect a bulb, something like this. So the bulb usually glows up na when it is a closed path, immediately current starts flowing through it. Okay, and immediately the bulb goes up, the blows up, right? So now we'll try to go ahead by marking the potentials, okay, in the circuit. So let us assume the potential exactly at this point it has 0 volts. Okay, if the potential at this point is 0 volts, immediately the potential at this point I have to consider it as what? 10 volts. So always between these 2 points, the battery will try to maintain the voltage of 10 volts. Now I'll try to go ahead. So obviously this will be 10 volts. Okay, this will be 10 volts and this will be 10 volts potential. Now why I have written entire on the top from this point to this point I have written it as 10 volts equally because the conductor is a equipotential body. So the conductor is a equipotential body, that is why I took the same potential throughout this loop from positive terminal of the battery to the positive terminal of the what you call it as the bulb. Okay, similarly the negative side, so I'll try to consider this is also 0 volts, this is also 0 volts, this is also 0 volts. Okay, now to understand further, what I try to consider in this entire loop, it is a single loop, same amount of current flows. Same amount of current flows means let us assume practically 2 amperes of current is flow. That means 2 coulombs of charge crossing in 1 second. That means the current flowing through it is 2 amperes. So that means the current coming out of the battery is 2 amperes. So I'll try to mark this one with a different color. So observe clearly. So the current coming out of the battery is 2 amperes. The current entering the bulb is also 2 amperes. The current leaving the bulb is also 2 amperes. And the current entering the negative terminal of the battery is also 2 amperes. So the same 2 amperes current will run throughout this single loop. So that is the idea. Now, then how the bulb is glowing? So what makes the difference? What makes the difference is something, the relationship between the energy, potential, and charge, it is equal to simply QV. Okay, so from this concept, so I'll try to mark this point as this point, I'll try to mark it as A, this point I try to mark it as B. Okay, now however, the same charge is moving throughout. Okay, same charge is moving throughout. Let us assume the charge at point A, that is Q at point A, is equal to uh, 2 coulombs. Okay, similarly the charge at point B, QB is also 2 coulombs, na? Because same charge will, the charge neither be created nor be destroyed. Neither be created nor be destroyed. So charge QA and QB, it is neither be created nor be destroyed, right? So that means whatever the charge is available at point A is the same charge is available at point B. So unfortunately, the charge is same, current is same. Then how the bulb glows? What makes the difference? The makes the difference. The charge is same, but the thing what is making the difference is the potential. Potential at A and potential at B. Unfortunately, potential at A is equal to 10 volts and potential at B is equal to 0 volts. This is the thing what is making the difference. So automatically the charge is constant, but the potential is different. Automatically the energy of the charges is also different. Now I'll try to go ahead to calculate the energy of the charges. A at the point A is simply QV. That means QA into VA. So QA is nothing but 2 coulombs multiplied with VA potential. So this is how much? 20 joules. Now similarly, the energy of the charges at B, point B, is equal to QB into VB. So which is equal to QB is nothing but 2 coulombs multiplied with VB. VB is something 0. So automatically the energy of the charges is how much? 0 joules. So whenever the charges are entering the bulb, so try to understand the concept clearly. Whenever the charge is entering the bulb, they are entering the bulb with 20 joules of energy, whereas when they are leaving the bulb, they're leaving the bulb with an energy of 0 joules. So energy neither be created nor be destroyed, right? So how this is what is happening here? Similarly, the energy is spent in the form of light. So how much energy is spent? 20 joules of energy in 1 second. Okay, 20 joules of energy is spent in the form of light. So whenever the charges are entering the bulb, they are having a lot of energy, and whenever the charges are leaving the bulb, they does not have any energy. So the energy is becoming unfortunately zero. Okay, then energy as I said earlier, it is neither be created nor be destroyed. Then who is giving the energy to the charges? So I'll try to extend this. And what I have connected here? The battery. Okay, now at this point, what is the potential? 0 volts. At this point, what is the potential? 10 volts. Now, what is the energy of the charges at here? Energy is nothing but how much? 0 joules. Okay, that is QV. QV. V is 0, na? So here, what is the energy at this point? Is equal to QV. QV is how much? 2 into 10. How much? 20 joules. Okay, so for better understanding, so I'll try to consider this as C and this as D. So this is energy of the charges at the point D, whereas these are the energy of the charges at the point C. So EC and ED. Okay, so now whenever the charges are crossing this battery, okay, whenever the charges are crossing this battery, there is gain in energy. Whenever the charges are crossing this bulb, na, there is a loss in energy. There is a loss in energy. So this is how the energy of the charges lift up by using the battery, whereas the energy of the charges is being lost whenever they're traveling through the bulb. This is how the energy gain and energy loss will happen. However, the energy neither be created nor be destroyed. So that energy what we are losing is spent in the form of what we call it as the light. Okay, so this now tell me what is important parameter that is making the difference. Even the charge is same throughout the loop, as the potential is different, automatically that is making the difference of energy, and how this is how the energy gain will happen and energy loss will happen. Okay, so with this lecture, I am concluding the concepts of this energy, potential, and the charge. So in the next lecture, we'll try to go ahead with some more concepts of current electricity. So thank you for giving this opportunity. This is Dr. E. Vijaya Babu signing off.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.